Identifying all the complex zeros for a polynomial function is a pretty involved process. These are long problems. So we want to take a look at several examples to make sure we're getting this idea down. In example 15, we have a third degree polynomial. So we're going to be looking for exactly 3 zeros. We can apply the signs test. Looking at the original function, we see 1, 2, 3 different sign changes, which means we're going to have 3 or 1 positive real zero. In this case, that's not a very definitive answer, but it does give us a way to look at our final solution and compare it against those two results. One of those two cases should be correct. If we consider g of negative x, we'll end up with negative x cubed minus 6x squared minus 61x minus 106. There are no sign changes, so we would expect 0 negative real zeros. From there, we'll start constructing our list of rational numbers, which are all possible zeros for our function. Looking at p, we need factors of 106, which will include plus or minus 1, plus or minus 2, plus or minus 53, and plus or minus 106. Our values for q would just be factors of 1, so we'll have plus or minus 1. Each of those numbers put over 1 would just result in those numbers again, so our list of values for p is the same thing as our list of values for p over q in this case. From here, we substitute values out of that list into our given function until we find one that gives us a result of 0. I know that plugging in 2 is going to give me that result I want, but if I didn't know that, I would just have to try values over and over again until I got that result. But if we were to evaluate g of 2, we would get 0, which would tell us that 2 is a 0 of that function. Which means the next thing that we want to do is take our function g of x divided by x minus 2. Setting up that synthetic division problem, would give us 1, negative 4, 53, and then 0, which is, again, what we'd expect. That remainder should be equal to 0, meaning that our function g of x can be factored as x minus 2 times what we have left over from that synthetic division process, x squared minus 4x plus 53. We have a depressed equation again, which is the remaining portion after we factor out that x minus 2. So the next piece then is to work on that depressed equation and find any zeros for it. Since this is a quadratic function, we can again apply the quadratic formula, which in this case would end up giving us 2 plus or minus 7i, which gives us 3 different zeros for x, 2 plus 7i, 2 minus 7i, and x equals 2. So our function g of x can be factored as x minus 2, x minus 2 minus 7i, and x minus 2 plus 7i. Where again we have a complex number and its conjugate, complex conjugate, both represented as zeros. We have 0 negative real zeros, and we had either 3 or 1 positive real zeros. In this case, just 1.